Today we're going over another one of the common types of related rate word problems, and this one is particularly dreaded by students, and that's the draining water tank. This type of problem can be intimidating compared to the other ones just based on the way that they're worded. For some reason, they just seem so much more technical than the others. But when you take a step back and look again, you can see that they're really not that different from the simple geometry problems that we covered when we looked at rates of expansion. So if you're familiar with cylinders, cones, pyramids, spheres, prisms, and you're comfortable with calculating their properties like volume and surface area, then you've already gotten through the hardest part. We're going to use this example problem above to break down this process into easy steps so that you can start solving problems like this on your own with just a little practice. And if you still feel like you need more help after this, please click the link in the description below. We can set up a free consultation to help you hit the ground running. So get out your pen and paper. Feel free to pause this video and run things back while you follow along, take notes, because we're going to be moving fast. Now let's get to work. As always, we want to get started by reading the problem and getting an understanding of it. And this problem says, a water tank shaped like an inverted cone has a height of 20 feet and a radius of 10 feet. The water tank houses a pipe at the vertex connected to a drain pump that extracts water from the tank at a rate of 3 cubic feet per second. Looking below, we can see that this is a two-part question. Let's just take it one part at a time. So part A asks us, what is the rate of change of the water level when the depth is 12 feet? And part B asks at the same moment, what is the rate of change of the radius? So this is how we do it. The first thing with this problem is that we have to understand the properties of a cone. When we look at the formula for the volume of a cone, we can see that the volume depends on both radius and height. We don't want to use both variables, radius and height, when we differentiate. So in our setup, we have to find some way to relate the two to each other. We can also see that as water drains out of the tank, the water level doesn't just drop in height, but the radius also shrinks at the same time. If we slice the cone vertically, we can see that the profile of the body of water compared to the entire water tank itself resembles two similar triangles, and their proportionality will be the key to defining this relationship. It also gives us a way to solve for the radius value at the time that the given height is 12 feet. Now it's time to list out our givens and include this relationship in the givens. That's because we're going to use this relationship to make a substitution to reduce two variables, radius and height, down to only one. In part A, the problem asks us to solve for the rate of the water level dropping. So we're going to substitute out radius and then simplify the formula only in terms of height. Now we're ready to derive. The differentiation in this problem isn't too bad, just power rule and chain rule, since we are deriving once again with respect to time. Once we plug in our given values, we isolate dH dt and solve. When we're simplifying, keep the value of the solution in terms of pi to get an exact answer rather than rounding a decimal. Part B of this problem asks us to solve for the rate of change of the radius at the same time that the height of the water level is 12 feet. This process is pretty much identical to part A, except this time we substitute out the height and define the volume of the cone in terms of its radius alone. The differentiation step goes pretty much the same way as before, using power rule and chain rule. And then we plug in our values and we try to solve for dr over dt. Once again, simplify your answer down to an exact value in terms of pi, and as always, make sure that you include the right units. When you break difficult tasks down into easier chunks, it makes things go a lot more smoothly. And this applies just as much to individual problems like the ones that we just worked out, as much as it does to your big dreams and your life ambitions. If you want to succeed in your calculus class and you're interested in one-on-one coaching, please click that link in the description below for a free consultation. I hope you found this helpful. If you did, please be sure to like this video and subscribe to our channel. Ring that notifications bell to stay in the loop for valuable tips to help you stay on top of school. New content drops every week. Also, if you're still trying to work through related rates, please be sure to check out some of our other types of related rates word problems that we broke down into simple, easy steps, including the one with the ladder sliding down the wall, or the person walking into the street light that casts a shadow, or the word problems that involve angles of elevation and depression. Until next time, this is Tauheed from Tutelage Tutoring signing off.